Hi, my name's Phil. I'm the host and creator of the Taming Hindrances podcast, where we talk about self-awareness and mental health. I also get into researching different topics, and today's topic is vitamins. So come along on what I call the Taming Hindrances podcast deep dives, which is where we try to tame hindrances in neural kinetics, or think. And in a deep dive, knowledge is knowing the answer and wisdom is knowing where to look for it. So today's deep dive is all about vitamins. But before we get started, disclaimer, not a doctor, not a professional, not an authority. I'm just an idiot on the internet. Do your own research, look into things on your own, take everything I say with a grain of salt, but specifically, please do your own research. It's important. Specifically when we're talking about vitamins, because there's a lot to go along with supplementation and vitamins as a whole, as a topic. So we're going to dive into that, and hopefully you'll come out on the other side with just some more information. At the end of the video, I'll have some final thoughts for you, specifically on what I've found during the research I've done. And also in the comment section below, there are links to vitamins and supplements that I've taken personally, either from a good quality company like purebulk.com or, something on Amazon that I just found was cost effective and also, good quality. So let's get started. Vocabulary is super important. We talk about that on the podcast. And today's vocabulary, I'll try to keep fairly short, but there are some things we need to know. First off, what's a vitamin? It's a naturally occurring nutrient, and it comes in different forms, and they're known as vitamers. So let's break down what a vitamer is, because you might hear that when you talk about vitamins. Vitamers are the related compounds that provide the body with specific vitamins in its category. So A vitamin, B vitamin, they are compounds all related inside of that the body will then metabolize into the specific vitamin forms that we'll use. So you'll get different ideas like bioavailability. We'll talk about toxicity and how metabolism works with all these. But keep in mind, not all sources of vitamins are the same, but they are classified the same. So you'll hear me say one type or another type. It's the classification of the research puts it in that vitamin class, but you can get it from different sources. So the current vitamin list is A, B's 1, 2, 3, 5, 6, 7, 9, and 12, C, D, E, and K. The letters that are missing are from just research that we either combined that vitamin into a different vitamin set, or we just found out that it wasn't a vitamin, so we don't include it on that list anymore. And when we're talking about vitamins, an important distinction you'll find is water versus fat soluble. Water soluble, obviously, can be dissolved into water, but specifically with water soluble, it's excreted from the body instead of being stored in tissue. And it's usually excreted through the urinary system, or goes through, which involves going through the renal system, which is your kidneys, and then, out through the bladder, where absorption can take place. So there's also that. And then that also includes the digestive system. So liver, stomach, pancreas, colon, which is your large intestine, and your ileum, which is your small intestine. And those are the C and all B vitamins. And then you have fat soluble. And this is where it's not dissolved in water and it's easily stored in tissue. That's an important distinction here, because most fat soluble vitamins will be stored in your tissue for use, which is where we can get into higher chances of toxicity because the body's storing it and using it. I will say toxicity is rare though. Again, I'm just an idiot. Do your own research. Fat soluble vitamins are A, D, E, and K. So let's get a little deeper here. Vitamins versus minerals, because we hear that a lot in supplementation. What's a vitamin? What's a mineral? Well, let's keep it pretty simple here. Both are vital nutrients. So you'll hear vitamins, vital nutrient. We'll have vital or essential minerals you hear a lot. So again, they're both vital nutrients, but they come from different sources. Vitamins occur in plants and animals, so they're organic, and minerals naturally occur in rocks and soil, so they're inorganic. Vitamins versus supplements is where things get a little bit more complicated. Think about geometry here. I know people maybe don't like math, but you have squares and rectangles. Squares would be your vitamins, rectangles your supplements. All vitamins can be supplements, but not all supplements are vitamins. So all squares are rectangles, but not all rectangles can be squares. Making it simple, vitamins are naturally occurring organic nutrients. Minerals are naturally occurring inorganic nutrients, and supplements are prepared versions of nutrients, either solo or in combination with others. And that prepared versions piece is what will make sense as we go along, because you can have bioactivated and those types of things as we get into with this little breakdown. In the vitamin world, you're going to hear a couple different things when it talks about sources. You'll have provitamins, you'll have esters, you'll have bioactivated, and you might hear the words liposomal. Liposomal is something that gets thrown a lot around with like vitamin C and those types of things. But to break it down a little bit, provitamins are the precursors, or the substances the organism can turn into vitamins. So we use provitamins as our precursor that we're going to turn into through metabolism, absorption, and those types of things into the vitamins we're going to use. The example of that, we'll get into it when we get to vitamin A, but you have beta carotene, which is the provitamin for vitamin A, known as retinol. This can also describe a synthetic version the body will metabolize. There's a lot of synthetic vitamins out there, or versions of vitamins that we've synthesized outside the human or organic system. Moving on, we have esters, which refer to an oxyacid or byproduct of the reaction. That's a byproduct of the reaction between an acid and an alcohol. Think animal and vegetable fats. Those are esters. Some pure vitamins are better protected for absorption by the gut biome via the addition of a sugar or fat. That's what makes it an ester. So again, think your vegetable fats and animal fats as an ester. Bioactivated versions of vitamins are substances that have been converted into versions that would naturally occur in biological use. So we get things like methylation, carboxylated versions. These are the versions of the vitamin that have already gone through a metabolized process where they get a methylation or carboxylation. So they're more easily absorbed by the body or easily used by the body is the way to think about that. Liposomal versions are any supplement, essentially, again, all vitamins are supplements, but not all supplements are vitamins, that is surrounded by a lipid barrier for better absorption. There's a bunch of different ways to go about that, but that's what liposomal really means. It's surrounded by a lipid so that it can better get through the digestive tract. Starting out with vitamin A, it's fat soluble, and the pieces of vitamin A that are what we consider vitamin A, the sources, are all your retinoids, retinol, retinal esters. Remember we talked about esters, retinoic acid. That's what we use it for, do with it. And then we have the carotenes, which are the carotenoids that do not contain oxygen. So there are carotenes that do contain oxygen. They're separate from vitamin A. The carotenoids that do contain oxygen, or that's what carotene is so you have carotenoids. They can be a chain that has either oxygen or non-oxygen. A carotene is the chains that don't have oxygen. And they're typically chained, if you look at, chemistry, 40 carbon with an X number of hydrogen. That can be multiples. That's why we have different sources for retinoids and carotenes, so we have to get into those. The retinoids are retinol, which is what we consider vitamin A1, and it's converted into retinol and retinoic acid. Retinol, AL, all forms of vitamin A are metabolized into retinol. So it starts as retinol, OL, and then it all gets metabolized into retinol. And it's the precursor for the other forms of vitamin A the body will use. Then we have retinol esters, which are the storage form of a vitamin A. So remember, it's an ester. Think body fats. If we go back, remember vitamin A, fat soluble. So esters are how we store it in the body. And then we have retinoic acid, which is the metabolite part of the metabolism, be it at the intermediate or end production. So it mediates the function of vitamin A. So it's the metabolite, the metabolism. It's part of metabolizing all vitamin A is that retinoic acid piece. We have carotene, which gets broken down into a couple different things here. So we have tetraterpenoids, which is a classification of terpene, which are biosynthetic building blocks. Anyone who's ever studied the cannabinoid system, the whole world of marijuana and all that stuff, will know how important terpenes are. Specifically, when we talk about cannabinoid strains, really the things that our cannabinoid system reacts to the most are terpenes. You'll also find terpenes in like things like essential oils and those types of things. So the tetrapterpenoids is what carotene is, and it's a classification of those terpenes. So carotene is a carotenoid that does not contain oxygen. We talked about that. But specifically here, humans do not have the ability to produce carotene. It's not something we produce naturally. So we look towards the plant world. Plants synthesize carotene, and that's what creates their pigmentation. You know, when people talk about carrots being orange and those types of things, that's where it comes from, is that plants use carotene as a synthesization process, and it gives them their pigmentation. So what's vitamin A really used for in the body? Well, one of those things right off the bat we've heard all our lives is vision. This has to deal with the retinol form, AL, specifically how our rods and cones react. So you have rods and cones in your eyes, and they're what allow light in and then deciphered into the picture we see as the world around us. And the two versions of that vitamin A has a role in is rhodopsin, which is our rods, and iodopsin, which are the cones. Both of those deal with the representation of what's considered purple on the spectrum of light. And that lack of vitamin A will sometimes lead to low-level light issues, not being able to see in low levels of light, specifically in the rhodopsin side, because rhodopsin is what we use to see. The rods are what we use to see in low-level light. Vitamin A also plays a role in immune functions as an antioxidant. Your T cell differentiation, which is cell types, and proliferation, which is the amount of cells. So you'll often hear me say differentiation or proliferation. Differentiation is your cell types. Proliferation is the amount of cells. It's the division of cells and making more. And vitamin A has a role in the T cell, in both differentiation and proliferation. Then also in hematopoiesis, which is the formation of blood components. So pretty important. We have your erythrocytes, our red blood cells. Those are the oxygen carriers. They move oxygen around the body. Then you have your lymphocytes, which are part of the immune system, and your myeloid, which is immunity and blood clotting. So think macrophages go in and they eat stuff and get it out of there, those types of things. We have bone, teeth, mucous membrane, and skin cell health, and that's all kind of combined all up here in one because there's a lot going on with retinoic acid. Retinoic acid helps maintain skin health by switching genes and differentiating immature cells into mature cells. Keratinocytes, epidermal cytes, go back to T cell differentiation. It plays a role in multiple different cell type differentiations. And it's used in your bone metabolism specifically for osteoclastic functions. Osteoclastic is bone destruction. So you have two cycles in bone health: osteoclastic, absorption of bone, and then osteoblastic is the creation of new bone. But vitamin A plays a role in the osteoclastic bone destruction function, which is super important in the body because we break down bone in the body to use in a bunch of other factors. So moving on, it provides cells with protection against viral, bacterial, and protozoan infections. An example of this is the expression of mucins, which are your mucous membranes, and keratin. That's your hair, nails, and skin. We use that to produce new hair, nails, and skin. Keratin's important. And then apoptosis, which is cell death. And that's important because apoptosis that gets left around, specifically when the macrophages don't come and clean it up, leads to inflammation, and inflammation is a pretty solid precursor to most disease. So vitamin A is doing both roles here. It's not only helping with the macrophage usage, it's also helping with the apoptosis, so the actual cell death itself, and cleaning out things like maybe oxidative stress. Vitamin A also plays a role in gene transcription. As retinoic acid is important for gene transcription. We've heard that when we talk about DNA and RNA. So it's the first step in gene expression. And retinoic acid receptors are found all over the body, and they are regulatory nuclear receptors for gene transcription. So that's where retinoic acid comes into play. So without vitamin A, we can't do gene transcription, which is bad. There will be a slide like this for all the other ones as well, but I get just, quick supplement forms and food sources. I'm really not going to get into food sources, but I will talk about supplement forms because that's where we see things like the provitamin form. So beta carotene, provitamin form of vitamin A. Remember, that's the precursor we're going to turn into vitamin A in the body. And then we have vitamin A palmitate. That's a synthetic alternative used in supplements for food products, also known as an ester version. And you'll see when we talk about supplement forms, there's a lot of things like fortification. And fortification is when we add things to foods. So in the food sources, you might see fortified foods. That's when we use one of those synthetic alternatives to boost the levels of whatever vitamin we're targeting in those food groups. Moving into the vitamin Bs. Vitamin Bs are all water soluble. There's 1, 2, 3, 4, 5, 6, 7, 8 of them. 1, 2, 3, 5, 7, 9, and 12. The ones that aren't there are vitamin Bs that we've just kind of combined into the other ones, or again, we eliminated like we did with the normal vitamin letters. So vitamin B is commonly known as the B complex, and they're all related as to the relationship like in the body. It's just all these B vitamins all kind of have the similar reactions in the body, similar uses. That's why they're all included under B vitamin, just numbered differently. Vitamin B1 to start out is also known as thiamine. All of the B vitamins have another name they're known by. That's the chemical compound in which they are, and then we just label them as a B vitamin. So thiamine is B1, and it's important for metabolism. Metabolism is the way we use energy. So it's necessary for what's called ATP production, and ATP is how your body moves. We use ATP production in all muscle, growth, use, action, all that stuff. ATP it's the energy source of the body. So vitamin B1 thiamine is what helps convert carbohydrates into glucose. And it also helps break down proteins and fats. Again, that's how we get to that ATP production. We have to produce the other fuels we're going to use to do ATP. It's an immune system supporter through energy production, like electrolyte transport in the cells. Electrolytes are those essential minerals and things that we're going to, and salts and those types of things that we're going to use as another kind of energy source to make it super dumbed it down. But it also plays a role in brain and nerve function. So along with ATP and glucose production, thiamine is used in the creation of myelin, which protects the nervous system throughout the body. I'll get into myelin in another slide when we talk about myopsin and those types of things. But myelin is a protective sheath that your body produces around your nerves. Again, we'll get into that in another slide here, which will give you a kind of a key in of how all these B vitamins work together. So supplement forms for vitamin B1, thiamine mononitrate, that's the non-hygroscopic, and then thiamine hydrochloride, HCl, which is the hygroscopic. Hygroscopic is absorbs water. So when we're supplementing B1, there's the ones that are not going to be absorbed by water, and then the ones that will be absorbed by water. Keeping in mind, all the B vitamins are water soluble. B2, riboflavin. This is one of those examples where it was formerly vitamin G. We figured out it works with all the other B vitamins. We put it in to the B vitamin area and got rid of vitamin G. And now we have vitamin B2, riboflavin. It's important for metabolism, as all the B vitamins are, and it helps convert food into energy, ATP production. We talked about that. This one specifically helps break down proteins into amino acids, which are our building blocks. We need those all throughout the body. Supports helpful functions and systems, including but not limited to hair and skin via collagen levels. Collagen is the cellular structure in nature we use to build skin. Your skin is made of collagen. Again, sometimes I oversimplify things, but that's kind of a way of thinking about it. Immune system as an antioxidant, specifically in the production of glutathione. I'm not going to get into glutathione in this video, but glutathione is just a crazy good antioxidant, and you should go look at glutathione and what it does in the body. It's super important, specifically good with getting rid of oxidative stress and those types of things. And then also B2 plays a role in the cardiovascular system via red blood cell production and transport of oxygen to the cells. Remember, we've seen that before with vitamin A and how it also does the whole red blood cell things. You can start to see how vitamins really start to work together. B2 supports absorption and the use of other vitamins that include the production of B6. We'll get into that. But it's due to a flavin adenine dinucleotide, which is FAD, and flavin mononucleotide, FMN, which are all cofactors. And you'll hear me say cofactors again. Cofactors are chemical reactions inside the body. FAD is required for converting retinol and retinoic acid. Like I just said, we're talking about vitamin A with the red blood cell production. Here it is. Again, vitamin B2 having an interaction with that. And then FAD is used in converting tryptophan to B3. So we got a B6 thing, a vitamin A thing, a B3 thing. They all kind of come together. B2 riboflavin supplement forms, riboflavin, and riboflavin 5-phosphate. That's going to be the bioactive version. Anytime we have it's phosphatase we added a phosphate to it. So you have riboflavin 5-phosphate, which is what the body is going to naturally produce with riboflavin. So that would be its bioactive version. B3, niacin. This one's kind of super important, but they're all really important. But getting into it, it's a precursor for two coenzymes that together regulate over 400 processes in the body. So we have nicotinamide adenine dinucleotide, NAD. That's a hot term nowadays, the NAD production. And that's found in all living cells. You get NAD in everything. And specifically, it's used in the redox reactions. Redox reactions are the chemical reactions where an electron is transferred. You can have a loss, that's oxidation, and you can have a gain of, that's reduction. This is happening constantly in your body all the time, doing all sorts of different processes. We also have nicotinamide adenine dinucleotide phosphate, NADP, which is a cofactor, remember chemical reactions, in the anabolic cycle of metabolism. Anabolic is when we're building things. Catabolic is when we're destroying things, in case you hear me use those different terms. Again, anabolic, building, catabolic, destroying. So here it's being used in the cycle of metabolism as an anabolic, so building, and the example here is cholesterol synthesis. We also have ascorbic acid synthesis, and we have the ascorbic acid. There's a whole cycle to that, and it does synthesize some fatty acids. So it's doing a lot of things. It aids the following systems and processes. These are 4 of your 7: digestive, endocrine, immune, and circulatory. So it's doing a lot of things. Remember, it's found in all living cells in the form of nicotinamide adenine dinucleotide. Supplement forms are niacin. Niacin is typically fast release, and then we have niacinamide, which is typically a slower release or less flushing. When you take a B3 vitamin, when you take niacin, you're going to have what's called flushing. And some people aim to get this because what flushing does is it kind of pushes everything out towards your skin, which is why we call it flushing. Your skin gets flush. We usually feel it in the axials or limbs. That's the term for limbs, is axial. So you feel it in the axials. People get it in their hands. It feels like your hands are swelling. Face usually, scalp. Forearms is where people feel it a lot. Sometimes, and there's heat to go along with that. So it's important to note for niacinamide, at doses over 100 milligrams, it is notable that different actions occur. So niacin and niacinamide. Niacin balances HDL and LDL cholesterol, and then niacinamide promotes a healthy insulin response and supports joint health. That's the doses over 100 milligrams. Doses under 100 milligrams, they kind of both have the same effect. So they're kind of interchangeable there. When we get into the higher doses, which would be, anything over 100 milligrams, that's when we get the flushing stuff. You'll get it under 100 milligrams too. It's just body dependent. Everyone's a little different, but doses under 100 milligrams, again, they're interchangeable. Doses over can be used to target specifically cholesterol or insulin response and joint health, depending on which version of the supplement you take. Remember though, just an idiot on the internet, do your own research. Moving on to B5, we have pantothenic acid, and it's found in nearly all food sources. This is something that a lot of biological things use, so we find it in most food sources. And it's a requirement for coenzyme A synthesis. That's not to be confused with vitamin A. It's used in both anabolic and catabolic. Remember, anabolic building, catabolic destroying, and specifically in the synthesis of fatty acids. And it's used in the citric acid cycle via pyruvate. We talked on B3 about that, ascorbic acid, but it's the citric acid cycles. It's all part of that. So all of this is combined with vitamin C to do other things. And pyruvate is what we find in the Krebs cycle and keto-related functions. So anybody who's working on their Krebs cycles or getting into keto, this is important. It works in multiple functions necessary for life, such as creating lipids, may help with cholesterol levels. Lipids are your fats in your body. Then we have neurotransmitters, which are our nervous system. It may help with brain and neurological activity there because it helps in those functions. And we also have hemoglobin, and hemoglobin is the oxygen carrier in red blood cells. So as I talked about before with red blood cells and them carrying oxygen throughout the body, they do that using hemoglobin. B5's pantothenic acid, that whole story in the hemoglobin world, in the red blood cell world, it comes into factor when we're talking about wound healing, and specifically also in the immune response and just overall cardiovascular health. When the body's able to carry oxygen where it needs it more effectively and easier, it helps with all those things: immune response, cardiovascular, wound healing. When we're talking about clotting, when you talk about clotting factor, you want to kind of look at B5 a little bit too. Supplement forms, provitamine of it is pantothenol, and then you have pantothenate, which is typically found combined with calcium for stability. So you get D-calcium pantothenate, which is a salt. You could consider that an ester by the process in which they do it. B6, pyridoxine, is involved in multiple functions. One of those is the conversion of tryptophan to niacin, known as B3. We talked about that before. And then we have synthesis of neurotransmitters. We're talking neurotransmitters on B5. These are the chemicals our body uses in both the nervous system and provided by the endocrine system to do things. So we have serotonin and dopamine. Those are two of the big four. Actually, all the big four are all here: serotonin, dopamine, epinephrine, neuroepinephrine. I'm sorry, I'm missing one. Part of the big five, I should call it. One we're missing is the stress hormone, cortisol. But serotonin and dopamine are your quote unquote feel good part of the feel good drug setup. Dopamines are what we get as the reward drug or reward hormone that we get when we do things that we like, and our body goes, yeah, here's some dopamine, it makes us feel good. Serotonin is just like the mood stabilizer. So when we get that dopamine rush, we don't like crash off it. We get like a serotonin level. So B6 has a lot to do with our mood and how we feel things. And then we also have gamma aminobutyric acid, which is known as GABA. One of the big things GABA is important for is getting deep restorative sleep. So not REM sleep, non-REM, rapid eye movement, REM. Non-REM or deep sleep is a lot of those like watches people wear to check their sleep cycles. That's where one factor GABA comes into. So it's really important for healing of the body is, if we have that GABA and we're getting into a deep non-REM cycle. It's also involved in hemoglobin synthesis. We talked about hemoglobin before. Glucose metabolism, energy production. Remember, going into ATP again. And metabolism of multiple amino acids. So it helps break down amino acids, which are, building blocks, and then we use that for different stuff. And there's 6 chemically related compounds that all make up vitamin B6. Pyridoxine, pyridoxal, and pyridoxamine, plus all the 5-phosphate versions of those. That gives us all 6. And the relation is, in the chemical world, is the pyridine ring it has, which is a chain of 5 carbon, 5 hydrogen, and a nitrogen. That's the chain it makes up. That's the compound form of it. It also aids in regulating homocysteine, which is an amino acid And homocysteine levels they're kind of important here. Hyperhomocystinemia is correlated to endothelial cells damage. Endothelial cells are the cells we find in the interior lining of the blood and lymphatic vessels. So homocysteine levels are the regulation of that, which is what B6 is helping with, is what keeps our body from allowing hyperhomocystinemia from happening. And that all correlates to damage in the lining of the blood and lymphatic vessels. So really important. Homocysteine is also a precursor to inflammation, specifically again in the cardiovascular system, which is where we find blood and lymphatic vessels. Remember, I'm not a doctor. I'm just an idiot. In my personal opinion, inflammation is the precursor to just about all major disease. So vitamin B6 helping in the regulatory process for cardiovascular system inflammation, very important. Supplement forms. Pyridoxine HCl, cheapest of the 6 to produce. So it's usually how you find it. And then you get pyridoxal 5-phosphate or P5P. That's the phosphorylated. So they add a phosphoryl group. Remember, we had those. There's the 3 major forms that can be considered B6, and then they all have their 5-phosphate forms, which gives us the 6 chemical forms. Well, it's all because those extra 3 we added a phosphoryl group, which is phosphorus and oxygen. And you'll find that in a lot of things. When we look at a phosphoryl or what's considered a phosphate, that's the adding of a phosphor and an oxygen. That happens in a lot of metabolic processes. So pyridoxal 5-phosphate would be considered the bioactive version. And it's, again, just the phosphate version of pyridoxine. And it's the cheapest one of those to kind of produce is the pyridoxine side. B7, biotin, which is formerly vitamin H, is related to metabolic functions, specifically those for energy production. Remember ATP, we're going to get into that again. So it's glucose utilization, which glucose is typically what most people use for their energy production. We also have the Krebs and the keto cycles, but glucose is the usual one. And it helps with carboxylation. And the carboxylation is the addition of a carbon dioxide to a compound that ends up becoming a carboxylic group. And this process is used in many important coenzyme functions, like a ton. And it goes all the way down to the mitochondrial level of ATP. That's, again, energy production, ATP production is all at the mitochondrial level. So think about it as using carbohydrates, fats, and amino acids in all the different functions in the body. That's what biotin helps with. Biotin is also specifically found in our bone, hair, nail, skin, and nervous system health. Deficiency of it, most people hear, I'm deficient in, I don't have a lot of biotin, so I have brittle hair and nails. We hear that a lot. And then it also helps maintain bone marrow, which has to do with blood cells and nerve tissue. And then as a note, I'm totally oversimplifying this. Biotin is like used everywhere, and there's a bunch of what's considered biotin dependent functions in the human system. I just kept it simple with the bone, hair, nail, skin, nervous system. There's a ton of other things. Again, mitochondrial level use of ATP. Supplement forms are pure biotin, which is its solubility may vary. So if biotin as a pure supplement gets exposed to air that's humid, it can cause clumping, and it's not always the most soluble thing in the world. It always kind of varies. So you have biotin 1%, which is blended with mannitol, which is a sugar substitute, which is alcohol-based. So again, think ester here, and that's highly soluble. You'll find that there's a lot of supplements, versions of vitamins that are called 1%, and that's where it gets mixed with something else. Again, ester version to help with being used in either production or just in actual supplementation use. B9, folate or folic acid. This one gets deep. So it's used in the production of DNA and RNA via purine and pyrimidine, which are the metabolism versions of those. So stepping into it, they're both nucleobases. So purine and pyrimidine are both nucleobases. Nucleobases are biological compounds that contain nitrogen. Why is that important? Well, these are nucleosides. Okay, so nucleobases form nucleosides, which are used in nucleotides, which are part of nucleic acid polymers. Why is that all important? Well, the nucleic acid polymers we talk about most are deoxyribonucleic acid and ribonucleic acid, known as DNA or RNA. So B9 folate or folic acid is used in DNA and RNA. So that's why it gets real deep as to how it helps in the metabolism production of, or how DNA and RNA get created and used. That's why it's kind of a deep one here. So we also have methionine synthesis, and that's a substrate for amino acids. So if amino acids, remember, building blocks, the substrate, or how they're formed, essentially, that's what methionine is a synthesis for. So big one, glutathione. I've talked about that before. It's a great antioxidant the body uses or produces. You can take glutathione supplementation. Again, do your own research. Then we also have taurine, which is bile in the large intestines. It helps us break down things as we digest them. And cysteine, remember, go back to homeocysteine. Cysteine is the translation of mRNA for polypeptide production. Peptides are a super important topic for modern medicine because those are the amino acid chains that make up all of these different things we're using. So you can take polypeptides nowadays. A common one, you'll take a collagen peptide. That's a common peptide we're using in today's society. But methionine synthesis, which is what B9 helps with these amino acid substrates to build these. So it gets pretty deep into that level. B9 is also super important for pregnancy. Lower deficient levels have been linked, like straight up linked, to neural tube defects. The neural tube is the precursor to what we consider the central nervous system. You can think of it as the spinal column when the embryo is in development. So if a person going through pregnancy is deficient in B9, folate, folic acid, it may turn into what we consider the birth defect of poor neural tube structure. And that's a huge issue because it's where the central nervous system is housed during the embryo's development, and then again becomes the spinal column and the nervous system as a whole. B9 is also related to multiple other health functions or issues, including but not limited to cardiovascular via B12 activation and the role of homeocysteine. We talked about that before. Deficiency linked to some forms of cancer. It's been shown. Red blood cell production via division and replication, muscle growth, and it may have an effect on mental health, which is why it's kind of important in all these different things. You look at all the cardiovascular, red blood cells, muscle growth, mental health, all sorts of things going on here. A quick note, the forms of supplementation here are important, so we're going to go over those. Supplemental forms of B9 are pure folic acid, which is used in a manufacturing and professional production. Pure folic acid is dangerous to consume without professional intervention. So it's nearly impossible for you to buy pure folic acid without essentially submitting some sort of form or at least signing a disclosure saying like you're not going to sue somebody because they sold it to you. So everyone's body reacts to it differently, and some do not synthesize into a usable form, which that can lead to toxic levels. Even though it's a water soluble like all the other B vitamins. L-methylfolate is the activated form of folate. So that's typically the version you might find. Anytime you see here a methyl anything, it's the bioactivated version. So one of the versions of B9 you can typically take, or what you'll find in a lot of B9 supplementations, like a B complex, those types of things, is L-methylfolate. The body can typically use it even if you have what's considered MTHFR mutation, that's a genetical mutation, which doesn't allow you to absorb folate or folic acid normally. So it's a biological metabolization issue is the MTHFR genetic mutation, again, not being able to absorb it. So getting the already bioactivated version, as I talked about bioactivated versions of anything, is what your body's going to do with the vitamin or the vitamer. And so if you already have that process happen ahead of time, methylation in this case, your body doesn't have to do that, so it can just absorb it and use it instead of having to try to go through the metabolic process, which you may have a gene mutation that doesn't allow you to do that. So that's why that's important. Let's move on to B12, cobalamin. Cobalamin is a name for cobalt. It's a coordination complex. All B12 is cobalamin is a coordination complex of cobalt. And that just means it has a central atomic structure that's similar. And that makes it, it's cobalt central atomic structure. And then it's the complexes that are those. And it has similar functions to B9. It's a cofactor in DNA synthesis and fatty and amino acid use. It aids in the function of the nervous system. Remember I told you we'd get into this in myelogenesis, which is your myelin. And the myelin sheaths that go around the nerves are super, super important because it protects the nervous structure, but it does that in a specific way when it comes to nervous system use. One of these, as an example, are the nodes of Ranvier. And the nodes of Ranvier are the myelin sheath that go over the nervous system, and they are spaced out so that you can have something called saltatory conduction. Saltatory conduction is how we send signals down the nerve pathways. So anytime we have a degradation or an issue with the myelin sheaths around the nerves, we cannot complete the process of saltatory conduction correctly unless you get nerve misfiring, nervous system issues, all sorts of terrible things can happen. So B12, important for myelogenesis, important for keeping a healthy nervous system. And it also plays a role in lowering homocysteine levels. Remember B6 and B9. So you have hyperhomocystinemia. Again, it's correlated to endothelial cell damage. That's something we talked about already. And we have it also helps produce red blood cells. And anyone deficient in B12 is going to have a direct link to their anemia. So that's the lack of production. A deficiency in B12 is directly linked to anemia. Again, lack of production of red blood cells. And then, we have not getting oxygen around the body, bad day. Possible health benefits and uses are mental health, including serotonin production for mood stability, also nervous system use. Cognitive function, again, if the myelin sheaths aren't working and we're not getting saltatory conduction, we're not getting proper nerve signaling. And then it's also used in energy. Many energy supplements use methyl B12. So that's like all those different energy supplements out there, all those energy drinks, they're using a methyl B12. You can take a methyl B12 as a sublingual. That's just one of the things you can do. Instead of taking an energy drink, you can just drink straight methyl B12. Supplement forms. You have pure cyanocobalamin, which is used in manufacturing and professional production. Cyanocobalamin and other forms of cobalamin supplements, they all include cyanide to varying degrees. That's what the cyano part of cobalamin, cyanocobalamin, cyanide, cobalamin combination. So the pure forms are not sold to the public at large. That's just kind of similar to the last one we talked about. You just can't buy the pure form. So remember the 1% thing. You can get cyanocobalamin 1%, which is blended with mannitol. Again, the ester. That's purchasable by the public. And then you can also get the bioactivated versions like methyl B12. Again, found in most energy supplements or as a standalone sublingual version. I have one of those I take almost every day for energy. Link in the description below for that. Vitamin C, water soluble. Humans do not have the ability to produce their own source of vitamin C. It's a very important fact. So what is vitamin C? Well, it's ascorbic acid or ascorbate, and it aids in the immune system and supports healing. As an antioxidant to both reduce or prevent oxidative stress, It helps with collagen synthesis and wound healing. That strengthens the skin and protects it against infection. And it's involved in various blood-related processes, such as white blood cell production, and enhances iron absorption. Remember, anemia prevention, so along with our B12s, B9s, all the other B vitamins. It's a cofactor in the production of the neurotransmitters serotonin and norepinephrine. Neuro just means before, so precursor to epinephrine or adrenaline rush in the adrenal cortex. Serotonin, remember that mood stabilizer. And then other supplements interact with vitamin C in all sorts of various processes. So the citric acid system or cycle in the body is the ascorbic acid process. And there's all sorts of things going on. A little too much to get into here. It's super important for all their processes. That's why lack of vitamin C can lead to some nasty health issues. One of those being scurvy. So there's that whole process. I would suggest a deeper dive into vitamin C because there's a lot of misinformation. I don't want to use the word misinformation. There's a lot of information that gets into different things. Like, does it prevent the common cold? Can you take it when you get the common cold? It's useful to have ahead of time is my answer on that. Remember, I'm not a professional in anything, not a doctor, not an authority on anything, but vitamin C is useful to have in the body ahead of time because that's what allows it to get used in all these different processes. Supplement forms. Ascorbic acid. It's there. You can take it. Comes in powdered forms. It's typically provided in its L form, which is the bioactivated form. So it may show up as L-ascorbic acid. That's just, again, the bioactivated version already. And it usually comes in a powder. You can mix into things. Or if you're getting in a pill, the pill is just the casing for the powder. So you can just get ascorbic acid powder and mix it into stuff. You also have ascorbyl palmitate, which is the ester. That's combined with palmitic acid. And then there's calcium ascorbate, which is, it's kind of catching on because it's the buffered version. So buffered is another way of saying, not liposomal, but like better for digestion. Because it's buffered with calcium ascorbate lowers the acidity level of the ascorbic acid. Thus, it's like a little bit, like it's better on people's stomachs. Because if you take a large dose of vitamin C, a lot of people will tell you, if they've ever done it, your stomach does not like that so much. So this is a buffered version, and you get calcium with it too. So there's that. There's also the liposomal variants. So again, a lipid surrounding vitamin C. That's important to note because when we take vitamin C, again, sometimes the stomach doesn't agree with it. In those instances, the stomach bile will break down the vitamin C before we absorb it. So there's always this conversation about absorption when it comes to supplementation, specifically vitamins. So what a liposomal version of vitamin C will do is allow for better absorption or higher absorption percentage. I specifically myself take a liposomal version of vitamin C because I find I get a better absorption, and thus I don't have to take as much. And again, with the stomach stuff, you don't want to be like having to take tons of vitamin C powder because your stomach's just not going to be happy about it. You do get used to it over time, but that's another discussion. Vitamin D. Vitamin D is so important. So let's get into that. It's a fat-soluble vitamin, and it's a group of specific subclasses of steroids known as secosteroids. So there's numerous vitamin Ds. And the most important, though, for humans are cholecalciferol, which is D3, and ergocalciferol, which is D2. And vitamin D is a vital nutrient, thus it's a vitamin, but we also must consider it's also a hormone in most mammals. And most mammals will synthesize enough through proper sunlight exposure, but it's the modern day, and we don't always get as much sun as we could. So vitamin D calciferol is what it's called, and there's a lot going on here, so let's break it down. The body will synthesize cholecalciferol in the epidermis layer, so it's the upper layer of skin, when exposed to sunlight, specifically the UVB radiation of sunlight, which is the ultraviolet UVB range. And for those who really want to get into it, it's the 280 to 315 nanometer on the Hertzian frequency list that gives us that light spectrum. And the conversion process in the body is the liver converts D3 and D2 into metabolites known as 25-hydroxyvitamin D. When you get a blood panel done to look at your vitamin levels, they will look for the 25-hydroxyvitamin D levels because that's either your cholecalciferol to cholecalciferol, which is the 25-hydroxycholecalciferol version, or the ergocalciferol D2 to 25-hydroxy-ergocalciferol. So the liver turns it into the 25-hydroxyvitamin version. There's the two listed out for you. And then in the kidneys and some immune cells, vitamin D will be used through hydroxylation. And where we see that is in calciferol, which, remember, is the 25-hydroxycalciferol version of cholecalciferol, into calcitrol. So the kidneys or some immune cells using hydroxylation will turn calciferol into calcitrol, which is a hormone. Remember, we're talking about vitamin D is also a hormone. And that's its biologically activated form. Now, calcitrol, we're just talking about that, is used for modulating gene expression via vitamin D receptors, known as VDRs, in numerous organ cells, including those found in the heart, the brain, skin, and reproductive organs. It also maintains calcium and phosphorus levels. So it does this through calcium absorption in the intestine. So we need calcitrol to help the intestines absorb calcium. In the parathyroid hormone via serum calcium levels, and bone formation via osteoclastic and osteoblastic. Remember, clastic, consume, blastic, build functions. So that's important for how we use calcium throughout the body in bone health, and bone health has a lot to do with immune health. So vitamin D has a huge, massive role in immunity. And we can also see that in calcitrol's use of for cell differentiation or proliferation. Remember, differentiation, cell type, proliferation, increase of, or cell division. Example here, I like to talk about vitamin D in the immune system. So white blood cells such as activated T and B cells, which are your hunter killer cells, as well as monocytes. And it also does a bunch of other functions in different systems. Let's talk about those for a second because there's a ton. Now, a bit of a disclaimer on this one. The following is a list of systems, processes, interactions, conditions, possible treatments / preventions for, or other claims vitamin D may or may not have an effect on. Immune system, inflammatory response, cancer, bone health, cardiovascular disease, diabetes, weight loss, mental health, all-cause mortality, asthma, lung health, Alzheimer's, renal disease, osteoporosis, rickets, ADHD, IBD, hypertension, autoimmune disorders, all sorts of stuff. Vitamin D has so many roles in the body and so important for so much stuff. I urge anyone listening to this to look at their vitamin D levels, think about how much sunlight you're getting, and really dive even further into this and figure out of how much of an impact that might be having on your health. Vitamin D supplement forms. We have cholecalciferol powder. This is typically used in making supplements or tinctures. It's not typical that someone would take that as just like I'm just going to buy a box of that. Like that's not, it's usually in something. So like your multivitamin, if it has vitamin D in it, it's typically in the form of cholecalciferol powder. What we typically take in the supplement form is you'll find D3 plus K2 soft gels. The reason for that we'll get into when we talk about vitamin K, but it's almost an adage to say you should always take D3 with K2. It's nearly always beneficial to do that. Remember, they're not a doctor, so do your own research. And that's specifically because we'll get into it with vitamin K, but K2 regulates calcification, and overabundance of D3 in the body may cause calcification, and that's when things calcify. Not a good time, specifically if arteries calcify and those types of things. We don't want that. K2 helps regulate that. Vitamin E. Vitamin E is fat soluble, and it's known as tocopherols and tocotrienols. There's also the alpha, beta, gamma, and delta version of all these. So there's 8 vitamin E sources in total. It's an antioxidant in both an active and passive protection form. So it has a hydroxyl group that easily donates a hydrogen atom to free radicals. This allows those free radicals to be scavenged. So vitamin E is usually just chilling out. Remember, it's fat soluble, so it's typically stored in the tissue of the body, and it's just hanging out, ready to donate a hydrogen atom to any free radical that's running around, and thus making that free radical now hydroxylized or hydroxyl acid or group, which allows it to be scavenged up. Like the macrophages come along and go, hey, you're not supposed to be here, and then it eats it and gets rid of it. Oversimplification there. But again, it's stored in cell membranes, and that's because it's fat soluble. So because of that, this is the active and passive role here. So its active role would be to donate a hydrogen atom, thus securing the free radical and allowing it to be scavenged, or because again it's stored in cell tissue and the cell membranes, it's just hanging out, and that cell is then less susceptible to oxidative damage. If a free radical or oxidative stress radical comes around, it can just go here, have a hydrogen atom go away, and thus protects the cells from that issue. In our cell and system health, it's multi-purposed. Again, stored in the body tissue and used for transport of cell. It's used in transport across cell membranes, both in and out. It allows, so things come in and out of our cells all day long. Vitamin E is kind of like a gatekeeper. It goes, hey, you're supposed to be here, come on in. Hey, you're not supposed to be in the cell, get out. And it does it both ways. There's not a lot of things in the body that regulate transfer across cell membranes in both directions. It's typically a one or the other. Vitamin E is one of the rarer things that allows for both the transport in and out of cells. Super important. We don't just want to be letting things in and out of the cells. That needs to be highly regulated, and vitamin E is used for that process. It also protects and helps absorb vitamin A. And its specific role in doing that is with red blood cell proliferation or increase in red blood cells. It's an enzyme regulator. The example here is kinase or phosphorylation of proteins used in muscle growth. Phosphorylation is necessary cellular. It's a necessary cellular process. So it's that phosphorylation. Remember we talked about phosphorylized other vitamins that we were talking about, the version of them that's phosphorylated, 5-phosphate, those types of things. This is an enzyme. It helps that regulation of that process. One of those is kinase, which is used in muscle growth by protein use of amino acids, those types of things. Vitamin E is also used in gene expression, and that's its cell cycles we were talking about. Red blood cell proliferation, that's vitamin E is used in that process, specifically when we're talking about gene expression and how our genes express all sorts of different processes. One of those is how our cells cycle, proliferation, differentiation, those types of things. As a note, just like we talked about with vitamin D, the following list is a list of systems, processes, interactions, conditions, possible treatment/prevention for, or other claims vitamin E may or may not have an effect on. Macular degeneration, cataracts, cancer, all-cause mortality, Alzheimer's disease, cardiovascular disease, Parkinson's disease, cholesterol levels, hair, skin, nails, and muscle health, and strength, and repair thereof. So, like vitamin D, super important in all sorts of different processes. There it all is. It's a long list. If you really dive into vitamin D or vitamin E, you get into lists of research done for different things it may help with. It's long and kind of surprising. Some of the things you get into, like, wow, like that could help with that. Holy cow. Supplement forms: D-alpha tocopherol oil, succinate powder, or acetate powder. So it's all D-alpha tocopherol or tocopherol. It's one of the two versions, and it comes in oil, powder, different versions in that way. Vitamin K, fat soluble, and vitamin K is phylloquinone and menaquinone, and this includes structural similar vitamins that are all share that quinone ring. That's what makes up these. So Phylloquinone is K1, menaquinone is K2. And they both have this interaction. They're called GLA proteins, or the GLA domain. That's carboxyglutamate proteins. That's GLA, which is the GLA domain. And that GLA domain is a group of proteins with vitamin K dependent carboxylation. So that's the chemical addition of a carbon dioxide to form a carboxylic acid group. All of the GLA domain is all these proteins that have a vitamin K dependency for that acid group to be created. One of those is blood coagulation. So it's the proteins in the domain include factors 7, 9, and 10, thrombin, and proteins C, S, and Z. These all have to do with blood coagulation. And often if we have blood clotting issues, they'll talk about your factors, your blood clotting factors. Well, vitamin K plays a role in that GLA domain of factors 7, 9, 10, also thrombin, and the proteins C, S, and Z, which all of which are used in blood coagulation. Super important. If you get a cut, if your blood's not coagulating, it's not going to stop that bleeding. So these are literally need vitamin K to stop the bleeding if we have a cut. It's part of the process. It also includes proteins related to bone health, cell proliferation, cell migration, and the pancreas. Examples of import here, we've talked before about osteoblasts and osteoclasts. Well, there's osteocalcin, and that's secreted by osteoblasts. And what osteocalcin does is it helps bind calcium directly to the cells, and that regulates calcification. So it either allows it or doesn't allow it. And that's why we take vitamin K2 with D3. Because if we're taking D3 and we're getting a ton of calcium absorption, vitamin K will regulate how much of that is allowed in the osteoblast formation system. Remember, osteoblasts form bones. So when the calcium tries to directly attach itself to a cell, K can say, well, osteocalcin, which is part of those GLA proteins that are dependent on vitamin K, can say, hey, nope, you don't need to be here. Hey, you do need to be here. So it provides protection to over-calcification of different cell tissue. And another example is a hormone as a non-carboxylated form, which is found in, there's fat cells, muscle, pancreas. That's what osteocalcin also does, found in all those different sites. A note on sources. Phylloquinone, K1, is typically found in plant-based sources. Plants use it for photosynthesis. Animal-based sources are usually the menaquinone, which is K2. The body does a really good job of recycling vitamin K. So most diets have a readily available amount of vitamin K because then the body will recycle it. Supplement forms. MK4, which is menaquinone 4, it's the bioactivated version of menaquinone. And as an addition to D supplements and multivitamins, some K complexes do also exist, but it's usually as an addition, again, to a vitamin D or a multivitamin supplement. That's usually where it's found. So that is the end of all of the vitamins. Now we get into some notes. As I do deep dives, I keep notes regarding different things that I've found along the way. One of those is toxicity, because toxicity is constantly talked about in the vitamin world about should people be allowed to supplement. There's even been some legislation, and I wouldn't be surprised if more is produced to limit over-the-counters, to limit what you can buy supplements-wise. And they specifically, the group that's getting into the legislation about this wants to make it so that your doctor would have to prescribe vitamins. Personal opinion on that, it's bullshit. Apologies for the language, but no, that's what I found about toxicity. One, it has to do with water-soluble versus fat-soluble. Water-soluble vitamins, you'll just send it through, you'll send it through the kidneys. It'll do what it needs to do, but it essentially gets pushed out in the urinary system. You just get rid of it that way. This is that whole thing about, if you take too much vitamin C and your urine turns different colors. I'm not saying try it. I'm just saying that's a thing. It's a water-soluble vitamin. Most of those, C and all the B vitamins, you just get rid of the excess through the urinary system. Fat-soluble is where toxicity levels typically will occur. So yes, some vitamins can be toxic. It's based on a person-by-person cases. Everyone's different. A heavier person such as myself, I can take more vitamins. I can just take more anything because my body has more stuff to do with it. There is an onboarding process to some vitamins as well, such as vitamin C. If you start taking high doses of vitamin C, like I was talking about, you're probably going to feel sick. Your stomach's not going to be happy about it, but your body gets used to that over time. So it's common to find you can onboard vitamins at a slower pace and then up the doses later. Some provitamin forms, they don't get metabolized into their vitamin forms quickly enough to become acutely toxic. So there's that. Again, water soluble versus fat soluble. Then there's all the RDVs and upper limits. Upper limits are country to country in some cases, and that's the upper limit they suggest that you can take before toxicity happens. There's different versions of upper limits, and there's different numbers I've found, so just keep that in mind. Vitamins may also become toxic or damaging over time and can have interactions with drugs or other supplements being taken. That is an important thing to note. As far as toxicity levels go, they vary, but vitamins can become toxic or damaging and will have interactions with drugs and other supplements. So it's just important to note that that's a possibility. Again, though, everyone is different. It's not one size fits all. There's no one size fits all like research out there. They've touted it as that, but it's just, in my opinion, not true. We'll get into that when I get into health claims a little bit. Absorption levels. Everyone's different. Same thing as before. Everyone's different. Everyone gets different absorption levels. It's how your gut biome's working. It's how your gut health is working, your system in general, how it's working. There are higher absorption rate versions of stuff. When you talk about multivitamins, there might be, or supplements in general, it might be like high absorption percentage. That's verbiage to keep in mind. And then there's also the biologically active versus the biologically available versions. So each version might have the bioactive version. There might be the liposomal, remember that. So that's when we were talking about provitamin, ester, bioactivated or liposomal. That's where all this kind of comes in, is what's the absorption level going to be? Everyone's different. The higher absorption level, the better, because the less you have to take. I did not get into optimal times to ingest, optimal versions, empty stomach versus meals. That all requires way more research than I did here. And it's all, again, person to person, and even specific to the supplement itself, to the vitamin itself. Each one can be a little bit different. Health claims. Super, super important to note this. While researching all vitamins, recurring statements were found about almost all intake levels. Quote, not enough research has been done, or quote, many claims of health benefits, but no substantial evidence. I found those claims all throughout. This culminates in what can be conflicting studies and intake recommendations. Specifically, when we're talking about RDVs, recommended daily values, upper limits, those types of things, as well as conflicting or lack thereof for information regarding health benefits of supplementation. There's evidence that recommended daily allowance RDVs and upper limits are not based on proper or enough research. Systems like orthomolecular medicine also exist, in which high levels of vitamins are used to combat or prevent health issues. In almost all cases, it would seem that there would be a benefit to more research being done, but all current statements, as they should, do insist on caution. I'm totally okay with that. It's always better to be cautious. But it cannot be stressed enough that everyone is different and you should do your own research and consult with trusted medical sources. I wouldn't even consider myself one. I'm just providing you information. Please do your own research. Your body is so much different than someone else's body. Nature versus nurture, stress levels, hormone levels, all of these different things, gut biome. But there are systems out there like orthomolecular medicine that treat specific diseases using high doses of vitamins. I'm not saying that's the answer for you, but there's a ton of research going on, and there even needs to be more about treating certain diseases with vitamins instead of following the big pharma method. And that's all I'm going to say on that, because you get in trouble if you say any more. But big pharma may not be right. Your best way to go about this is to look at a blood panel, a vitamin blood panel. That's something you need to talk to your doctor about. And you're looking for optimal vitamin levels. Then you can look at higher doses of vitamins and the treatments for different things. There's been plenty of studies to say how vitamin D, C, and E can all help treat cancer. Okay, there's a lot of information out there. Go about looking at it in your own pace, at your own will. But here's some final thoughts. This is just opinion. I can't say it enough. I say it way too much. I know. Do your own research. There is enough scientific and anecdotal evidence to support the necessity of maintaining optimal vitamin levels in the body. I don't think that's arguable. I think if we look at optimal vitamin levels, they support just natural immunity, all systems of the body. That's why they are vitamins. They're vital to our health. Without a foundation of necessary nutrients, the body cannot perform as designed. Proven. Lack of vitamins and minerals at sufficient levels allow for vectors of disease and its precursor, inflammation, to destroy homeostasis. I struggle not to get super active about that one, but please look into vitamin D and how that can prevent disease, specifically when it comes to viral vectors and bacterial vectors into the body. Also, vitamin E and its free scavenging radical when when we talked about vitamin E, those two particularly. Everyone is different, but understanding one's own body is integral to staying healthy. Recommended daily values or RDVs may not fit your health situation. Again, going back to optimal vitamin levels. Keeping in line the adage of everything in moderation. We can use supplementation to prevent disease or restore homeostasis where disease has taken over. We just need to remember that everything takes time, typically more than we want it to. I fully believe, and it's my own opinion, and I'm not a medical professional. This is not medical advice. I'm not a professional in any way or an authority on this subject, but it's my personal opinion. Use of supplementation of vitamins can either A, treat disease or prevent it. It depends on the levels, and we need to give it time. You can't just take a huge dose of vitamin C or a huge dose of vitamin D and hope it just fixes everything. It's more about a constant regimen of supplementation to keep our vitamin levels at a high enough level in the body. There's different measurements that are used. Things like you can use, there's nanograms per milliliter, those types of things. That's what the blood panel shows. That if we keep them at a high enough level, we can either prevent or restore our bodies back to homeostasis when disease is present. So we can either prevent disease or we can restore homeostasis after disease has taken hold. That's my personal opinion. So this has been the Taming Hindrances podcast, deep dive into vitamins. There's affiliate links to vitamin supplements in the description below. I've used all of those. Everything I link to when it comes to affiliate links or products in that manner, I have tried. And the reason I link it is either it's from purebulk.com, which is one of the greatest supplement sites ever. They have a huge, massive list of supplements. You can use Taming Hindrances as a 10% off code at their site. I trust them completely. You can request quality control logs from them, all sorts. They're just a fantastic source for supplements, including vitamins. And then also there's some Amazon links to just supplements I've taken or specific vitamin versions I've taken that were either a good quality, like Zao Nutrition or Micro Ingredients. Another, they're great companies, but their quality is good, but also the cost-effective nature there. Sometimes, supplementation can be touted as like, oh, this is the best or that's the best. I like to look towards cost effectiveness at that point. My cost effective breakdown, I usually look at absorption level to how much it costs per dose. That's how I go about that. You can do your own research on that or your own calculations for your own personal use. And the full write-up of this can be found at taminghindrances.com. thanks for coming along. Hope you learned some things about vitamins. That whole like, subscribe thing if you want to, or come check out the Taming Hindrances podcast where we talk about mental health and self-awareness, or head over to the website to check out all sorts of other things. There's product reviews, deep dives like this, and other stuff like the archive where I, link out other sources of information that you can use. So as we say on the podcast, take care and just remember to breathe.